So in my previous videos, I have discussed on how to make counter circuits very easily using Arduino. And in this video, I am going to show you how to make counter circuits very easily using programmable counter ICs, such as this 74LS169. According to me, this is a very good programmable IC, and here comes the pin descriptions. The pin number 1 is up down. This means that if you connect pin 1 to high, then it will give you an up count, and if you count it to low signal, then it is going to give you a down count. Pin 2 is the clock, then pin 3, 4, 5, 6 are the load inputs. Pin number 7 is this CE pin, which is active low input. It is actually count enable pin. This means that if you goes low, then it is going to give count, and if it goes high, then it is going to hold the count. Pin 8 is the ground pin. Pin 9 is the program enable pin, and by which and later I am going to tell you how to use this pin. Then pin number 10 is count enable trickle, which is also an active low pin. Then pin number then 11, 12, 13, 14 are the output pins. Pin number 15 is the ripple carry pin, because by this you can carry out your count to a different programmable IC counters to get your pin. And pin number 16 is the VCC pin, that is the power pin. So here is the circuit which I am going to make, and from these terminals I am going to get the output that I have actually made on this breadboard. So before going to this, let's discuss what I am actually doing here. This pin, if you connect all this pin like this, and this pin number and this pin number this is actually as 7 to low, and pin number 9 to high, then you are going to get us up to mod 16 counts. But if you adjust these two pins, you can get different mod counts. Now first things come, that if we want to stop our count at a particular variable, then the first thing which we require is a reset. So let's learn how to reset this IC. So to reset this IC, here is our pin, the pin 9, which is program enable, which is active low input. This means that if program enable goes low, then it is going to print the load pins. The load pins actually L0, L1, L2 and L3. Here in this case I have connected to ground because I want that IC to be reset. This means that the state goes back to 0, 0, 0. If the PE pin goes low, then it is going to show this load. And one of the best thing is, if you again put this pin to high, then it is going to count from this low. This means that we can use this pin as a reset pin by connecting the loads to ground and by controlling this pin. Another thing we require is to stop the count where we want. For this we can use the CE pin, which is also active low input. This means that if this pin goes high, then our count will hold at that moment. So by using logics, we can stop our count and we can also reset our count. So let's see how we can do that. For this I need a truth table. For general purpose, here is the outputs which I am going to get. Now in this case I am going to make a mod 10 counter. So my count will end at 9. So first thing which I am going to make, that it is going to form a ring, that is from 9 it is going back to 0 and continuously form a ring, for which you have to look at this truth table. Here you will find that each in these cases is 1, except when it is 1, then we want that our program enable pin goes low, and at that time this CE pin goes continuously low. At that time it is not 1. So if you make your truth table like this, you will get your answer as program enable is Q3 Q0, which should be connected with a NAND gate. Another thing by which we can hold the count is by making this PE pin continuously high and this CE pin here at 1. At that time the PE pin will be continuously high. So I've also made the logic for which is actually Q3 Q0, and I've connected it with the AND gate. So here comes and that is the thing which I've actually made on this breadboard. Here comes our clock, and here is my 74LS169, and here are the load pins which have connected to ground, and here is the count enable trickle pin, and here are the outputs in the reverse order. This means that you are going to see the output very appropriately. Here I have made two push button switches to control where to stop and where to release. These push button switches are actually enabling these ICs. This one is activating this IC, this one is activating this IC. So by making this push button switch, we can control our counts at any moment. So let's do that with our power. Now first of all, I want to take a very quick IC. So you should count very fast, and here you can see it is counting very fast, and here we are getting all the mod 16 counts. And if you can see carefully, it is giving all my 16 count. So how it would be nice if I print this on a 7 segment display using a decoder. So let's quickly do that. Okay, so I have connected my Arduino module, and here you can see it is counting very well, and here you can see now it is giving all the mod 16 counts. That's why I've used a hexadecimal decoder system. If you look it very carefully, you will find this result. Now what would happen if I want to if I want that my counts ends at 9? So for this I have to enable this push button switch. This will activate this IC, and because of which my count will end at 9. So let's quickly do that. Let me at first end this count, and here it comes. Now I am going to enable this IC. So now if you see it very carefully, my count will end at 9. And here as you can see, my count is ended 9, and it is continuously formatting. Now let's check another thing, which is that my count will end at 9, and also it will stop its count at 9. So let's see that. And here as you can see, my count stops at 9. Let's see it in another way. At first let complete this all counts. Here this is actually happening because I am not enabling any of these ICs. I am using push button, that is it is for me continuously formatting. And now I am going to show you this. I am going to enable this one IC. This means that it is going to stop my count at 9. Let's have a look very carefully. And as you can see, the count ends at 9. So this is the thing which I've actually made here. And not only that, by this way you can stop any of its count. The main principle is, if you look it very carefully here, that this CE is actually Q3 Q0. This means the extreme most outputs, the Q3 and Q0. So whenever this one will be high, and if you press that push button switch, it is going to end. It is going to stop it count there. So let's quickly do that. So at first it comes 9. So if I hold it, then it is going to end at 9. But if I release it, is going to go back 0. Again I can stop my counts at B, because in this case if you look here very carefully, the MSB and the LSB are 1. Here is the main principle, that when my MSB and LSB are 1, then at that time we can stop our count at any time. And in C I am not going to start. Again D, here we can also stop, because you can see the MSB and LSB are 1, so we can stop our count here. If we release this, then E, and finally F, we can stop our count at 8 very easily. So in this way, by using this IC74LS169, you can see you can make any type of programmable counter circuits using this logic. You can make a mod 4 counter. You can also make a mod 16 counter. Sorry, it's absolutely mod 16 counter. Also mod 10 counter, or any type of counter using this IC. So this was this video is the last video on counter which I'm going to have uploaded here. And let me know in the comment section below that how was the video, and if you like the video, then please like my video, and please subscribe my YouTube channel, because very soon I will be uploading videos on many electronic things. So thanks for watching, and see you in the next one.